Okay, good morning friends. We were discussing module 3 part 1, functions having two variables x and y, random variables x and y. We already defined its probability density function f of xy, then the marginal distribution function f(x(x) of x and f(y) of y. Today's class is leading to covariance between the relation between the variables x and y. In the last class we discussed independent, whenever they are independent, f of xy is equal to f(x(x) into f(y)y. That was the previous class. So today we are starting with expectation function. Already defined in previous modules for discrete and continuous random variables. In discrete case, expectation of x raised to n is equal to sigma over x into x raised to n into f of x, where f of x is the PDF of the random variable x, and continuous case it is integral over x raised to n into f of x dx. It is the PDF, probability density function of the random variable x, expectation of x raised to n. We are taking expectation of x raised to n because our aim is to find the mean and variance. Mean is expectation of x and variance is expectation of x square minus expectation of x the whole square. So this function is defined for any function, not only for x raised to n. You can take any value here, any function of x here, then that function will automatically appear here. So our aim is to find expectation of x square, etc. Therefore we are defining expectation of x raised to n. Now the aim is how to evaluate the expectation function of functions having two random variables, say x and y. So it is also defined as whenever x and y are discrete, expectation of x raised to n into y raised to m is equal to sigma over x, sigma over y, x raised to n, y raised to m, f of xy. If it is continuous random variable, it is integral over x, integral over y, x raised to n, y raised to m, f of xy, dx, dy. This is the concept behind expectation function. You can replace this x raised to n, y raised to m by expectation of xy, expectation of x plus y, expectation of y square plus x, etc. Any function having two variables inside the bracket expectation, that function will appear here. If it is discrete, we are summing together x with respect to x and y. If it is continuous, we are first integrating with respect to y, then with respect to x, or reversing the order of integration. Whatever be, our aim is to find expectation of functions having two random variables. So for an example, consider a probability density function f of xy is equal to x plus 2y by 18. Take discrete case, x plus 2y by 18. X can take the value 1, 2 and y can take the value 1, 2. So as in the previous class, we are using the help of a tabular representation here. Okay, one value for x, x is here and y is here. Y can take the value 1, 2, x assume the value 1, 2. So when x equal to 1, y equal to 1, 1 plus 3 by 18, 1 plus 2, 3 by 18. When x is equal to 1, y is equal to 2, 4 plus 1, 5 by 18. When x is equal to 2, y is equal to 1, 2 plus 2, 4 by 18. When x is equal to 2, y is equal to 2, 4 plus 2, 6 by 18. This is the probability density function of the random variable xy when x assumes the value 1 and 2 and y assume the value 1 and 2. The previous class we defined f(x(x), the marginal distribution function f(x(x). We are adding to the 5 plus 3, 8 by 18. Here it is 4 plus 10 by 18. This is the marginal distribution function of x. And here Fy, it is the marginal distribution function of y. 3 plus 4, 7 by 18. It is 5 plus 6, 11 by 18. One more point was there. If it is a probability density function, total sum must be equal to 1. So it is 8 by 18 plus 10 by 18. It is 18 by 18 equal to 1. Here also 7 by 18 plus 11 by 18. Answer is 18 by 18. It is equal to 1. So f of xy is a probability density function having two variables. Whenever a probability density function having two variables are given, how to find mean of x? Mean of x. That is the first question. How to find mean of x? Whenever we given function having two variables, mean of x is defined as expectation of x is equal to sigma over x into fxx. So remember the formula. The previous module, expectation of x was sigma over x into f of x, where f of x was the probability density function of x. Okay. Here the probability density function of x is not given. Instead of that one, we are taking the marginal distribution function of x, fxx. So how to find the mean? X can assume the value 1 and 2. So when x is equal to 1, corresponding fxx is 8 by 18. Plus, when x is equal to 2, it is 10 by 18, 2 into 10 by 18. So answer is 20 plus 8, 28 by 18. This is the mean of the random variable x. Expectation of x is equal to sigma over x into fxx. The remembering point is we are changing the probability density function of x with the probability distribution function of, marginal distribution function of x. That is the main difference here. And x is equal to 1, 1 into 8 by 18 plus 2 into 10 by 18, 20 plus 8, 28 by 18. Similarly, expectation of x square. Expectation of x square is equal to sigma over x square into fxx. The concept here, fxx. So x assumes the values 1 and 2, okay. X is equal to 1. 1 square into corresponding value is 8 by 18. This 8 by 18. When x is equal to 2, 2 square into 10 by 18. 2 square into 10 by 18. 2 square is 4. 4 into 10 by 18. 40 by 18 plus 8 by 18, that is 48 by 18. That is the expectation of x square function having two variables. How to find the mean? Expectation of x. So expectation of x square is equal to 1 square into 8 by 18 plus 2 square 4 into 10, 40 plus 8, 48 by 18. Then what is the variance of x? It is also defined in previous lecture. Variance of x is equal to expectation of x square minus expectation of x the whole square. This is the theory here. Expectation of x square minus expectation of x square the whole square. That is equal to 48 by 18 minus 28 by 18 the whole square. Similarly, expectation of y definition is sigma over y into f of y. F of y stands for the probability density function of y. It is a joint distribution function. F of y is not given. Fxy is given. Therefore, we are taking fyy, the marginal distribution function of y here. So, values please check. When y equal to 1, value is 7 by 18. Y equal to 2, value is 11 by 18. So, 1 into 7 by 18 plus 2 into 11 by 18, answer is 28 by 18. Expectation of y square, we are taking square of y. 1 square into 7 by 18. 2 square into 11 by 18, okay. 1 square into 7 by 18 plus 2 square into 11 by 18, answer is 44 plus 7, 51 by 18. It is okay. Then variance of y, expectation of y square minus expectation of y the whole square. Here expectation of y square is 51 by 18. Expectation of y is 29 by 18. So answer is 51 by 18 minus 29 by 18 the whole square. That stands for variance of y. So the next concept is expectation involving two variables, x and y. So expectation of x into y. Expectation of x into y. Definition goes in this way: sigma summation with respect to x, summation with respect to y, x into y into the PDF of xy, f of xy. Okay. So when x equal to 1, y equal to 1, the PDF value f of 1 is 3 by 18. So 1 into 3 by 18. When x is equal to 1, y is equal to 2, the value is 5 by 18. So 1 into 2 into 5 by 18. Then we are taking x equal to 2, x equal to 2, y equal to 1. The value is 4 by 18. So 2 into 1 into 4 by 18. Then x equal to 2, y equal to 2, 2 into 6 by 18. So total sum is 3 by 18, 10 by 18, 8 by 18, plus 24 by 18. Answer is 45 by 18. In the similar way, if we are taking expectation of x plus y, expectation of x plus y, summation with respect to x, summation with respect to y, f of xy. So summation with respect to x, summation with respect to y, x plus y into f of xy goes in this way. When x equal to 1, y is equal to 1, 1 plus 1, 2, 2 into 3 by 18. Is it clear? 1 plus 1, 2, 2 into 3 by 18. Then 1 plus 2, 1 plus 2, 3 into 5 by 18. 3 into 5 by 18. Then x equal to 2, y is equal to 1. 2 plus 1, 3 into 4 by 18. Plus x equal to 2, y equal to 2. 2 plus 2, 4 into 6 by 18. So it is possible to find expectation of any combination of x and y with respect to this tabular representation. In each case, we are taking f of 1, 1, f of 1, 2, f of 2, 1, f of 2, 2. Whatever be the function here, you are just x and y, change x and y accordingly. First we take x equal to 1, y equal to 1, x equal to 1, y equal to 2. Then we take x equal to 2, y equal to 1, x equal to 2, y is equal to 2. That's all regarding expectation in the case of discrete random variable.